Hello students, we continue with our doubts on alcohols, phenols and ethers. Let's begin. I move to question number. So we move to question number 8. That is phenolphthalein. Phenolphthalein is obtained by heating phthalic anhydride and concentrated H2SO4. Phenolphthalein is obtained by heating phthalic anhydride and concentrated sulfuric acid with phthalic anhydride and concentrated sulfuric acid. This is the structure of phthalic anhydride. Oh, we have done this in alcohol phenol ether, page 119. Our notes, AP 119, we have done this. You are asking same question. Okay. Again, it reacts with another molecule of phenol over here, NaH over here, and we treat it with concentrated sulfuric acid. So we are getting the structure which is, this is the structure of phenolphthalein. This is the structure of phenolphthalein. This is an indicator. So this is the structure of phenolphthalein indicator. Now students, because in this reaction we are getting phenolphthalein, this is also called phthalene reaction. This is also called phthalene reaction. So another name, phthalene reaction. Okay. Now we move to next question. That is, when I've already written the question, it saves time, you know. When phenol is treated with PCl3, that is phosphorus trichloride, then we should get chlorobenzene like we have learned. ROH with PCl3 gives RCl plus H3PO3, and RCl is the major product. But when instead of R we take AR, that is we take aromatic group, then we are not getting aryl chloride as the major product, but we are getting, that is what the question is. So when I take a molecule of phenol and I treat it with PCl3, then I get structure of this kind. This is the type of structure which we are getting. That is triphenyl phosphate. We get triphenyl phosphate. And we do get chlorobenzene. But the problem is this is the major product, while this is the minor product. So when phenol is treated with PCl3, then chlorobenzene is not the major product. The major product is triphenyl phosphate. So that is how the options are placed. They are asking you, okay, why because who is the other one? That is how the options are in the worksheet. So the one of the option is triphenyl phosphate, which is mentioned in this fashion. This is how it is mentioned, triphenyl phosphate. So that's the answer. Okay, that is the answer. Now we go to the next one. Picric acid and benzoic acid can be distinguished by. Picric acid and benzoic acid can be distinguished by. I think I will write the options here. Let me just check. I'm writing the options because you should understand the difference. I'll be solving 3 questions simultaneously now. I'll just write all 3. So picric acid and benzoic acid can be distinguished by. The options are aqueous. 1 minute, I'll just check. Yeah, the options are aqueous, NaOH, then aqueous, NaHCO3. Then we have, let me check what is the other option. We have been given aqueous, FeCl3 and aqueous, Na2CO3. Okay. So aqueous, FeCl3 and aqueous, Na2CO3. Okay. These are the 4 options. So how to distinguish between picric acid and benzoic acid? So now benzoic acid is a type of carboxylic acid. Benzoic acid is a type of carboxylic acid, and carboxylic acid, I'm just writing, this is benzoic, this is benzoic acid, and this is picric acid. Picric acid is 2,4,6-trinitrophenol. So the benzoic and the picric acid, the benzoic acid with aqueous NaOH, or this with aqueous NaOH, will give sodium benzoate, and this will give the 2,4,6-trinitro phenoxide. You can see ONA, ONA. Now they both are the salts, so they'll be in the form of a PPT. I'll see solid particles. But how will I understand that, okay, benzoic acid gives this kind of solid particle and picric acid gives that kind of solid particle? How will I understand that? Because both are white PPT. So I can verify that only when I see some color change. So we cannot use aqueous NaOH. Okay. Now next thing is, why can I use sodium bicarbonate? Okay, the next option, sodium bicarbonate, that is aqueous NaHCO3, aqueous NaHCO3, aqueous NaHCO3. Again, I'll get the salt and I'll get carbon dioxide and I'll get water. Carbon dioxide will give me effervescence. But still I can't distinguish because both the salts are again white PPT. और ऐसा नहीं हो रहा है कि एक में से तो कार्बन डाइऑक्साइड का बुड़ 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 दिख रहा है और दूसरे में कार्बन डाइऑक्साइड नहीं है. ऐसा नहीं है. दोनों में बुड़ 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 और दोनों में white PPT. So how can we distinguish? So we can't use sodium bicarbonate as well. Next comes aqueous FeCl3. Okay, if I use aqueous FeCl3, I use aqueous FeCl3, then this then picric acid with aqueous FeCl3 gives brown coloration. You can note it, students. Picric acid has phenolic -OH group which reacts with aqueous FeCl3 to give brown solution. You have learned this. The question was, give a chemical test to distinguish between alcohol and phenol. So the answer was alcohol with aqueous FeCl3, no coloration, but phenol with aqueous FeCl3 gives violet coloration. Now over here, the phenol is substituted with 3 electron withdrawing groups, which is now 2,4,6 trinitrophenol, which is also called picric acid, and this has the phenolic group, and we know phenolic group reacts with FeCl3. The only difference, when picric acid reacts with aqueous FeCl3, it gives brown coloration. So here I'll get brown coloration, but this will not give that color. So benzoic acid does not give such reaction, but picric acid gives brown coloration. So I can use FeCl3 to distinguish between benzoic acid and picric acid. Now the last option, why can't I use this? Now see, this and this is same, exactly same. सोडियम है, सोडियम दोनों का सॉल्ट देगा, सोडियम बेंजोएट एंड सोडियम फिनॉक्साइड, और साथ में यहाँ भी बुड़ कार्बन डाइऑक्साइड एंड वाटर मॉलिक्यूल. So you can't use sodium carbonate also to distinguish between picric acid and benzoic acid. Now here only I am introducing one question here. So your funda will get cleared. We will introduce one question here. One more question I am giving here. The question is, which of the following reagents, you can write, which of the following reagents is used? This is 13, so I am giving it question 14 numbering. Which of the following reagents can be used to distinguish between phenol and benzoic acid? Okay, अभी options हैं. I'll just tell you the options. I'll just see it in the book. The options are dilute HCl, dilute H2SO4, 5% aqueous NaOH and 5% aqueous NaHCO3. Okay, now see. Dilute HCl and dilute H2SO4 cannot be used. Phenol and benzoic acid cannot be distinguished using dilute HCl, dilute sulfuric acid, because phenol is a carbolic acid and benzoic is a carboxylic acid, and they are, oh, that everyone knows, they are acids. Correct? So, common sense. How can you distinguish one acid from another acid? Will it react differently? No, not at all. So acids cannot be used to distinguish between them. Next option is aqueous, 5% aqueous NaOH. Now, phenol with NaOH will give sodium phenoxide, and benzoic with aqueous NaOH will give sodium benzoate. Both are precipitate, both are the salts, white PPT. So you can't distinguish because phenol वाले में भी white PPT दिखेगा, benzoic वाले में भी white PPT दिखेगा. So how can I distinguish? So we can't distinguish. The last option is aqueous NaHCO3. When I treat this with aqueous NaHCO3, no reaction. When I treat this with aqueous NaHCO3, it gives sodium benzoate and water and the bud of carbon dioxide. So it gives effervescence of carbon dioxide. So I can distinguish because in one test tube I will see कुछ हुआ ही नहीं, दूसरे में I will see white PPT भी है और carbon dioxide का vapors भी है. This is only given by carboxylic acids. Only carboxylic acids give effervescence of carbon dioxide with sodium bicarbonate and sodium carbonates, where the best reagent among the two is the sodium bicarbonate saturated solution. Okay, one more question in the same category, very interesting one. The question is, which of the following is not soluble? You can just write. Which of the following is not soluble in? Which of the following is not soluble in aqueous NaHCO3? Which of the following is not soluble in aqueous NaHCO3? Okay. Once again, I am repeating the question. Please check what you have written. Which of the following is not soluble in aqueous NaHCO3? That is, which of the following is not soluble in aqueous sodium bicarbonate solution? Okay. I'm writing the option, okay, picric, benzoic, or nitrophenol, sulfonic. Okay, the options are, the first option is picric acid. The next option is benzoic acid. The next option is O-nitrophenol. And the last option is benzene sulfonic acid. Now we know carboxylic acid reacts with sodium bicarbonate to give the salt, the water, and the carbon dioxide effervescence. Sawal hai, which of the following is not soluble? तो ये तो soluble होगा, dissolve हो गया. अब carboxylic acid का जो भी strength है, what I am saying, I'll just write it in other color, strength. अब कार्बोक्सिलिक का, फिर सल्फोनिक का, ये सल्फोनिक है, सल्फ्यूरिक नहीं है, सल्फोनिक और पिक्रिक, इनका जो स्ट्रेंथ है ना ऑलमोस्ट सेम है, और जो कि बहुत ज्यादा है इससे फिनॉल या फिनॉल प्लस EWG, ये फिनॉल प्लस EWG इससे बहुत ज्यादा है, तो ये टेस्ट देगा, ये भी देगा क्योंकि उसके जितना है ताकत में ये भी देगा, ये वाला नहीं देगा. फिनॉल और फिनॉल with 1 EWG or 2EWG does not give sodium bicarbonate test. Not given. It is not given by those substances. Okay? I hope this is clear to everyone. Yep. Now we go to the next one. The reaction of this with HBr. अब देखो, whenever halogen acids attack the pi bond, whenever halogen acids attack the pi bond, the first thing that happens is you get a carbocation. ठीक है? अब इधर देखो, बहुत बढ़िया सवाल है. Here you will be getting, see, this one this carbocation, then you will get, what am I writing? Okay, then you will be getting this carbocation, okay, and you will be getting another place where cation formation will be there, and that will be इधर oxonium, इधर आ जाएगा positive. Okay, here the positive will come. अब ये सब कार्बोकेटायन में ना सबसे ज्यादा स्टेबल ढूंढना है. ये 2 डिग्री है, ये तो कार्बोकेटायन है ही नहीं, ये इतना स्टेबल नहीं है. ओके, ये 2 डिग्री है, ये भी 2 डिग्री है. लेकिन इसके यहाँ बाजू में ना अच्छा ERG है, एंड कार्बोकेटायंस आर स्टेबलाइज्ड बाय ERG. इसके आजू बाजू में ERG है लेकिन कार्बन वाला ही है, और ये ERG इससे दूर है. ओके, तो सबसे अच्छा कार्बोकेटायन ये बना, मोस्ट स्टेबल. तो इधर ही रिएक्शन आगे बढ़ेगा. Bromide will attack it, and we will be getting this as the product. So in the reaction with Br, go with the most stable carbocation. Don't go for this. Don't go for this. Okay? Here. An organic compound with molecular formula C3H6O. अब देखो, इसके ऑप्शंस लिख लेते हैं. क्या ऑप्शंस दिए हैं? Okay, they have given dimethyl ether, then vinylic, and then propanol, and then allyl alcohol. Okay, so the options are, one of the option is this, Chhatri O Chhatri. Another option is Chatu double Cha O Chhatri. Another option is propanol. And the other option is allyl alcohol, that is this. These are the 4 options. And I want to find the one who does not react with phenyl hydrazine and does not react with any metal. फिनाइल हाइड्राजीन से कौन नहीं रिएक्ट करता, और पहले देखते कौन करता है. तो फिनाइल हाइड्राजीन सिर्फ एल्डिहाइड और कीटोन से रिएक्ट करता है. तो एल्डिहाइड ऑप्शन नहीं हो सकता, बिकॉज उसने बोला डज नॉट रिएक्ट विद एल्डिहाइड कीटोन, does not react with 2,4-dinitrophenyl hydrazine, and aldehydes ketones react with phenyl hydrazine or 2,4-dinitrophenyl hydrazine. Students, this 2,4-dinitrophenyl hydrazine is also called Brady's reagent or the Bosch reagent. So ये तो नहीं हो सकता. Then does not react with sodium metal. Ethers don't react with sodium metal. बच गया ये दोनों. ये है C3H23456 C3H6O, ये भी है C3H6O. नहीं, does not react with any metal, does not react, यानी ईथर हो सकता है, अल्कोहल नहीं हो सकता, because alcohols react with any. Yes, they react. ये नहीं हो सकता, ये दोनों में से कोई हो सकता है. अब इसमें 2 कार्बन है और इसमें 3 है, ये मैच हो रहा है. So this is the answer, this is also not the answer. Okay? Fine? The last question is phenyl third butyl ether is prepared by using. Phenyl third butyl ether is prepared by using. I'll just adjust this. Just a minute. Yeah, you can see now. So phenyl third butyl ether is obtained by using. Okay. One of the option is C6H5ONA and 3 thrice CCl. अब देखो ये ऑप्शन रॉन्ग है. क्यों? हमने पढ़ा है any 3 degree alkyl halide on Williamson's reaction gives an alkene as the major product and not the ether. So this cannot be the option. B. C6H5Cl and 3 thrice CO-Na. This also we can't use because we have learned haloarine ka reactivity is very less. And they only give very few reactions which we have, in our syllabus. We have to go according to that. We have one with aqueous NaOH, that's the Dow's process, another we have with ammonia, and we have with CuCN, we have Fittig reaction, we have got Sandemeier's, Gattermann, Balskimen, but we don't have such a reaction, okay? So not possible. The last option is, okay, let me just check what's the option. Isobutylene with mercuric acetate and phenol followed by NaBH4. Yeah, this is the answer because when I take isobutylene, okay, and I treat it with C6H5ONA and another thing is HG CH, which thing they have given? Mercuric acetate. Okay, so OCO3 twice. So what will happen? Negative part of the reagent will go to carbon having less H. Markovnikov's rule, and I'll be getting CH3 CH3. इधर आ जाएगा OC6H5 और इधर आ जाएगा HgOCO3. Okay, now when you treat it with, I'll just shift the ball a little bit there. Yep, now it's visible. Okay, so then when I treat it with NaBH4, so reduction takes place and I get CH3, 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 and here OC6H5, which is phenyl third butyl ether. Okay, so I think the doubt solving is clear to you. Okay, love and blessings to all of you. Okay, bye bye.